Welcome. In this session, you are going to build your foundational understanding of operating systems, specifically focusing on Windows and Linux, the two dominant platforms in enterprise environments. Whether you're managing virtual machines in the cloud or troubleshooting local endpoints, this knowledge is absolutely essential. Think of the operating system as the bridge between you and the machine. It manages all hardware components such as CPU, memory, storage, I/O devices, and provides you with a platform to run applications. Without an OS, your computer would just be a pile of hardware with no way to interact or function. As you explore deeper into operating systems, you will notice they all perform a set of critical tasks, regardless of whether you're using Windows, Linux, or any other OS. These core responsibilities are what keep your system functional, secure, and responsive. You rely on the OS to handle multiple applications running at once. This is where process management comes in. The OS makes sure each app gets enough CPU time, manages the switching between tasks, and prevents conflicts. Without it, your multitasking experience, like streaming music while editing a document, would be chaotic. Whenever you open an application, it needs memory. The OS is responsible for allocating memory to each process while making sure one doesn't interfere with another. It keeps everything organized and safe in memory, so your apps perform smoothly and securely. You save files, install software, or retrieve data. Your OS is the one organizing all of that on the disk. It structures your data using a file system, manages permissions, and ensures data integrity, so you can always find what you need without confusion. From typing on a keyboard to printing documents, you are using hardware. The OS uses device drivers to translate your commands into actions the hardware understands. It acts as the interpreter between your system and all connected devices, keyboards, printers, network cards, and more. To keep your system secure, the OS manages user accounts, permissions, and access levels. Whether you're setting a password or controlling who can access a folder, the OS ensures that only authorized users and processes can interact with sensitive parts of your system. Finally, you interact with the OS through a user interface, either graphical GUI like Windows or command line CLI like many Linux distributions. The OS makes this interface available so you can easily run commands, launch programs, and manage settings. If you are working in a Microsoft ecosystem, you will frequently interact with both Windows Server and Windows Desktop environments. To manage and secure these effectively, there are a few core components you need to be familiar with. You will be working with NTFS, which stands for New Technology File System. It's the default file system in Windows and supports key features like file level permissions, data encryption, compression to save space, and quota management. These features help you enforce control over who can access or modify data on disk. Managing users in a Windows environment means understanding both local and centralized identity models. You'll use Microsoft Entra ID or Active Directory for centralized identity management, especially in enterprise setups. For local user and group management, you can rely on tools like computer management or automate the process using PowerShell. To keep your system running smoothly, you will use a set of powerful built-in tools. Task Manager helps you monitor running processes and system performance. Event Viewer allows you to investigate logs related to system health, application behavior, and security incidents. With services.msc, you can control which background services start automatically. And if you want to script or automate tasks, PowerShell gives you extensive control over system configurations. Security is tightly integrated into Windows. You have access to built-in tools like Windows Defender for antivirus protection, BitLocker for disk encryption, and Windows Firewall for network defense. You'll also use group policy to enforce consistent security settings across user devices, making it easier to apply company-wide policies without manual intervention. Linux is the backbone of many servers, cloud systems, and containers, and now it's becoming your playground too. Because it's open source, Linux gives you the power to customize, automate, and build secure environments exactly the way you want. When you navigate a Linux system, you'll start with the root directory, which is slash, which acts as the foundation for everything else. Directories like slash home, slash var, and slash etc. branch off from this root and follow a strict hierarchy. Linux uses file systems like ext4, xfs, or btrfs, each optimized for speed, reliability, and flexibility. Understanding this structure will help you store and retrieve files efficiently and securely. Managing users in Linux involves working directly with the files /etc /passwd and /etc group, which store user and group information. You will use commands like user_add to create users, password to set passwords, user_mod to make changes, and groups to check group membership. Once you master these, you'll be ready to manage permissions, ownership, and access controls with ease. You'll have powerful tools at your disposal. To monitor system performance, use commands like top, htop, and ps. For service management, systemctl is your go-to command. You can view system logs using journalctl and schedule tasks using cron. Most of your work will happen through the bash shell, your primary interface for running commands and writing automation scripts. Security is baked into Linux. When you need elevated privileges, use sudo to run commands as root. To control network traffic, you can configure firewalls using IP tables, firewall D, or UFW. For even stricter enforcement, you'll rely on mandatory access control tools like SE Linux or AppArmor. And for remote access, you'll use SSH to log in securely and manage your systems from anywhere. When you're deciding between Windows and Linux for a project, it's important to understand how they differ. Let's walk through these differences so you can choose what best fits your needs. If you're more comfortable clicking through menus and windows, you'll feel right at home with Windows. It's designed to be GUI focused and user friendly, making it accessible even for beginners. Linux, on the other hand, leans toward a command line interface by default. While many distributions offer graphical desktops, using the CLI gives you more control and flexibility, especially in server and automation work. When you use Windows, you are working with a commercial product. That means you'll need a paid license, which is common in enterprise environments. Linux takes a different route. It's open source and free to use. You don't pay for licenses, and you're free to modify or redistribute the code, which makes it ideal for developers, students, and large-scale deployments on a budget. As a Windows administrator, you will mostly use graphical tools and PowerShell scripts to configure settings or manage resources. It's highly visual, which helps if you're used to navigating interfaces. In Linux, you're expected to work directly from the command line using shell scripts and text-based tools. It might feel less intuitive at first, but once you learn the commands, you'll appreciate the precision and automation power it offers. You'll typically find Windows powering desktops, laptops, and business endpoints across corporate environments. It's tailored for end-user productivity and enterprise integration. Linux, by contrast, dominates in the backend. Think servers, cloud systems, DevOps pipelines, and embedded devices. If you are working in cloud administration or DevSecOps, Linux will be your close companion. Windows handles updates automatically through Windows Update. This means you don't have to think about patches. Though sometimes updates restart your system unexpectedly. In Linux, updates are manual or scripted using package managers like apt or yum. It gives you complete control over when and what gets updated, which is critical in environments where stability is key. So, what's your key takeaways? As a future Azure administrator or cloud engineer, you will deploy both Windows and Linux VMs in Azure, manage identities and permissions across platforms, monitor and secure systems using platform specific tools, automate tasks using PowerShell for Windows and Bash for Linux. Understanding these essentials means you're not just clicking buttons, you're building solid infrastructure.